Hi. Hi, my name is Robin Cooper, and I'll be giving this first presentation, about a 10-minute presentation. And this one will be put up on YouTube, and we'll be able to play it back and see how it goes. So what I have on one side of the screen is the PowerPoint, and I'll list the slides that we're on, and when I hit the arrow key for advancing within the slide, to the next text matter. Alright, so today's presentation is on some recent journal articles and a current topic related to deep tissue injury of muscle and the healing processes. I thought this would be an interesting topic and some recent work that's been forthcoming on this issue. So as we go to the next slide, slide number 2, you can see on the left-hand side the skeleton and the muscle that covers it. If you hit your arrow key there for a second, you see this little blue object at the bottom that then can push on the muscle and cause an injury, a deep tissue injury, by pushing the muscle against the bones inside of the body. So this is what's referred to as a deep tissue injury from an external force. And this could also cause an external wound on the individual. If you hit the arrow key, now you see on the top right another type of muscle injury. This is a muscle injury from, say, exercise or maybe a sprain where the muscle could be torn inside of the body. It wasn't necessarily from an external force, but the muscle is injured internally. And this can relate in swelling and then further muscle injury as the process continues. If you hit your arrow key a few more times, you can see that some text on the bottom. This can lead to this open wound that would not be good because of the risk of infection. These kind of wounds can then work their way from the inside out and then end up in tissue that would open up and then cause an external wound, or such as in the case of that external injury, it could also be an outside-in type of wound. And these kind of cases then could result in further tissue damage. If we go on to slide 3, you can see the process somewhat here that we're talking about. This deep tissue injury looks like the tip of the iceberg on the skin surface. See, at the very top there's just a small little bruise, but you see underneath that the wider tissue damage. And that can further grow and grow over time and cause even more problems than what you might not necessarily see on the surface of the skin. The suspected deep tissue injury really needs to be examined quite carefully, because this can then lead to what's referred to as a stage 3 or stage 4 pressure ulcer, where then you could have opening of the skin and further damage that can continue. And these are hard to cure in some cases. The cause of the deep tissue injury development is multifactorial and a complex series of events. If we go on to slide 4 here and then use your arrow keys, you can see that the bone muscle interface deformation is a case. Ischemia, where the blood can't flow through, can be a problem. And ischemic reperfusion injury is something to consider as well. When the blood reperfuses a particular site, this can actually even cause more injury. And it's the same thing in the brain during ischemic reperfusion as well. It's interesting. Impaired lymph drainage, where the lymph can't flow and take away that extra interstitial fluid, as we see here in the next couple arrows. Interstitial fluid buildup can also cause some problems, and then that can be a compartmentalization problem as well, and then impede even more lymph drainage or blood flow as the tissue swells up around it. From the damage itself, it could be the capillary walls increase their permeability, and that increases the edema and then increases the problem of lymph drainage and blood flow. Of course, there are inflammatory processes that will kick in and can cause problems. This can even lead to apoptosis, which is regulated cell death, and then further the problem even more. So going to slide number 5 now, one of the concerns is then how to prevent further muscle or tissue damage as a result of the primary injury. Well, we can see that basically you want to prevent the skin from breakdown. Use your arrow keys here, and you can see that increasing blood flow could be good to get the waste products, and that when a muscle's damaged, you think about the contents that escape out into the interstitium, a lot of proteins inside of the cells. Also ions like potassium. Increasing the blood flow and increasing the lymph flow could really be very helpful to get rid of these toxins that could further damage other cells, and the tissue damage then would grow. Apply heat. Some people think that might be good to increase the blood flow. Others maybe apply cold to decrease the swelling. Medications are also a line of defense. Anti-inflammatory medications such as non-steroidal ones to block the prostaglandins. Steroids are also thought to be very useful, such as to reduce the swelling. But the current recommendations for treating this type of injury are basically to treat it like it was a pressure ulcer. And these include repositioning, say the patient, if he's in the bed, reposition Marat so they won't have a bony protuberance sticking out on the bed and causing more tissue damage. Support surfaces such as like these waffle beds. Topical dressing applications to prevent the skin from breaking down. And of course nutritional support to promote healing. If we see in the last arrow key on the slide, at this time there's really no new treatment options for deep tissue injury to treat this. So what was really nice is these fellows here in Central Baptist Hospital here in Lexington, Kentucky, Jeremy Honacker and Michael Forston and some other colleagues were working to quantify this new type of approach to actually see if they would be useful to help healing suspected deep tissue injury. And this is with the low frequency ultrasound. And as you can see on page 6 here, they just published this in the International Wound Journal. And it should be out any time. It's a pre-press article's out, and it's on your web page also to download. If you go to number 7, slide 7 here, what they wanted to show was to determine if this ultrasound therapy would be useful, beneficial, and or would it be harmful, cause more damage potentially to the tissue. And this ultrasound therapy consists of delivering ultrasound at a low intensity, a low frequency, and it's a non-contact low frequency ultrasound mist. So there's no thermal effects on the healing. The low frequency ultrasound wave penetrates deeper into tissue as compared to longer waves. And as if we go to the next slide, you can see the device that's used here from the company that sells it. This is a picture from them. That there's a saline bottle, and then there's this ultrasound delivering device. The saline carries the waves to the tissue. As you can see here, that tissue then receives that ultrasound and it penetrates deeper into the tissue. And if you advance the slide a little bit, still on slide 8, but use the arrow keys, you see these little orange round objects at the bottom. The company advertises that this ultrasound can also kill the bacteria by breaking up the bacterial cell wall. So that's kind of an interesting process, but I didn't see any primary work on that with bacteria inside of the tissue being damaged from this technique. So for this study, they actually used 3 characteristics to quantify the suspected deep tissue injury. That's the STDI, to identify their severity. So they used total surface area, the skin integrity, and a wound color tissue assessment. And if you use your arrow key, you see that they had 3 different boxes here. One is the blue and the red and the green. In the blue box, they were looking at the total surface area of the injury spot. In the red box is the type of integrity, if it's intact or has a blister or the skin's broken. In the green box is the color of the type of tissue, if it was just a little bit pink or if it's necrotic tissue or not. And they would then add up these numbers and give that wound a particular score. So what they did is they had groups where they treated and had groups they didn't treat with the ultrasound therapy. And what they found out is that the ones they did treat scored better by 2.52 on this severity scale compared to the control groups without treatment upon the discharge. I didn't have time to go into the variables in this paper, such as which kind of wounds that they did not participate or did not include in this study, and some of the other factors that were involved. But in general, seeing that this increased wound healing. So there might be a beneficial effect of ultrasound therapy on this deep tissue injury. But this is what's so nice about this paper. This is one of the first papers that actually attempts to validate this whole process. And this is words out of Honocker's et al.'s paper here, and to actually put it to the test. Is it improving treatment or not? Well, what we're really interested in too as biologists is to understand the mechanisms behind this. If you can understand the mechanisms, and maybe even come up with newer therapies as well. Basically, they have seen an upregulation of endothelial nitric oxide synthase, which is NOS, to any kind of shear stress or this microstreaming of the muscle from ultrasound therapy. What does NOS do? There's a list here on slide number 11. It can increase the blood flow, change the muscular perfusion with the circulation. It decreases edema, and changes the oxygen delivery, nitrogen for free radical formation. It can upregulate the endothelial growth factor and decrease this TNF-alpha and interleukin-1. Decrease the cytokines, basically, so it decreases the inflammatory response. So what's next? Well, according to Honocker, they could show that this does suggest low-frequency ultrasound is capable of stimulating cellular activity through this mechanical energy without adding these extra growth factors or ATP or other enzymes. So that's pretty neat. What I feel that would be interesting to do with this study is to use this ultrasound therapy and to measure blood flow with Doppler techniques, maybe even measure some index of cellular metabolism such as glucose uptake. You could look at healthy tissue and give this ultrasound therapy and see how healthy tissue responds, for example. And then look at injured tissue as well, surrounding healthy tissue of injured tissue. This tissue perfusion idea with saline, I think, is something worth looking at, but I haven't really found anybody addressing this point. And that is to perfuse if the injury is a large injury and you have a lot of muscle damage, cellular breakage, then you're going to be spilling the potassium and all the proteins out into the interstitium. This could then enter into the blood supply, and that high protein level itself could actually end up in kidney problems where it blocks the glomerulus. The high potassium that could spill out and affect neighboring cells, that could actually depolarize neighboring cells and cause those to become leaky and end up with a growing tissue damage area greater than the onset where the first injury occurred. This potassium idea is not totally new. I mean, back in the 1930s, T.P. Feng knew that having higher potassium around cells could actually cause them to die. He took dying cells, the solution around dying cells, and added it around healthy cells and showed that they did not respond well. And a quote out of his paper, as you see in slide 14 here, is that crushed muscle with this concentration of potassium, if he takes crushed muscle and takes that potassium and puts that on, that's very damaging. And Sidney Ringer also had found this, if you raise the potassium concentration, you can have cellular problems as well in maintaining normal function. So that's quite interesting. It goes back to some old ideas and old literature, but basically high potassium is not good around the cells. So maybe envision future treatments with blunt trauma or bad tissue sprain is maybe promote perfusion of the region with saline or remove excess potassium in some way, a drain. Maybe that would actually improve the wound recovery. I don't know. Okay, I'm going to end right there, and that will give me about 10 minutes on the presentation. There's some further studies that I don't have time to talk about right now, but we can talk about them at a later time.